Performing precise static hand gestures in AR/VR often leads to errors and frustration. While one popular solution is providing visual tutorials, it can only support coarse gesture adjustments. In this paper, we explored different types of micro-level visual guidance for understanding hand gesture errors and facilitating fine-grained hand gesture adjustment and correction in VR. First, from an interview, we identified 4 types of information that users need in a gesture guidance system and extracted design guidance for creating effective visualizations. Based on these results, we designed 15 types of visual guidance that manifest different combinations of 4 essential information types. Then, in the second part of our formative study, we eliminated 7 overwhelming visualizations and evaluated the remaining 8. During the study, participants watched videos of the 8 types of visual guidance in action and ranked them at the end. Based on participants' preferences and feedback, we again selected and refined 4 types of visual guidance, one for each information complexity level. Now, we will show these 4 types in detail. With VG1, users can see which part of the gesture is incorrect. The orange balls show pose-related errors, while the purple outlined balls indicate proximity errors that only occur in double-handed gestures. VG2 is an enhanced version of VG1, not only indicating where the error is, but also providing directional guidance to facilitate joints and hand movements. VG3 adds additional information on VG2. In VG3, the length of the directional indicators changes according to how far a joint or key points is away from a target position. With VG4, users have access to all 4 types of information. The ball represents arrow positions and target positions. Lines connecting 2 balls indicate the direction in which to move and the degrees of deviation. And here are some additional demos of single-handed gesture performing with visual guidance. To evaluate the effectiveness of 4 visualizations, we carried out an experimental study, asking participants to perform 20 gestures with these 4 types of visual guidance and a baseline where no visualization was provided. For each gesture performing task, the user first puts 2 hands on the virtual table to start the task. After they touch the green sphere with the dominant hand, they can begin performing the gesture. The task is considered successful once the user holds the correct gesture for 1.5 seconds. The results of the study show that visual guidance significantly improved user gesture performance. Additionally, most users reported that the visual guidance did not hinder their immersive VR experience or their trust in hand tracking and gesture recognition, while increasing their confidence during gesture performing, compared to no visual support. For additional details and experiment results, see the company paper.